we want to understand what do we mean by a random variable. Let's first look at the context. Now, the idea is that listing details of random events can become very cumbersome. So, for notational and mathematical convenience, we will introduce the concept of random variables because we want to map outcomes of a random experiment to numbers. So, the main context over here is that they're meant for mathematical and notational convenience. So now let's precisely define a random variable. Now, given an experiment, the random variable takes on a real number for each possible outcome according to a specified rule. So in other words, it's just simply a function that maps outcomes in the sample space to real numbers based on a specified rule. So what we're saying is that you performed an experiment. The random variable is going to map each outcome in the sample space to a real number, and this is going to be based on some rule. This will make more sense when we look at two examples. Before that, let's just keep in mind, since we defined the random variable as a function, so we know for each function, every input gets mapped exactly to one outcome. You cannot have every input gets mapped exactly to one output. You cannot have more than one output corresponding to an input. So applying this to a random variable, which is a function, each outcome gets mapped to exactly one real number. You cannot have an outcome mapped to more than one real number. So if you have outcome one, it can be mapped to one number, say two. It cannot be mapped at the same time to more than one number. It cannot be mapped to two numbers. It cannot be mapped to three numbers, right? So because a random variable is a function, each outcome gets mapped to exactly one real number. But the same number can correspond to multiple outcomes. So it could be that both outcome one and outcome two correspond to number two. That's fine, right? So the thing to keep in mind is since random variable is a function, so so each outcome gets mapped to exactly one number, although it is possible that two outcomes can correspond to the same number. That's fine, that's not a problem, but corresponding to each outcome you should have exactly one number that it is being mapped to. Now let's look at examples to understand this. See, the first example is that we have a random experiment where we toss a coin. Now we will define this random variable x that maps head to 0 and tail to 1. So what we're doing is this is the random variable mapping that we're defining, where we're mapping the outcomes in the sample space head and tail to real numbers. So we're mapping head to 0 and tail to 1. Whenever you define a random variable, you are determining the mapping. This is the rule based upon which the random variable is going to map outcomes to real numbers. Here the mapping that we're defined is that map head in the sample space to 0 and tail in the sample space to 1. Right, so over here in the sample speed, head is mapped to 0, tail is mapped to 1 by the random variable x. So like I said, it's a function that maps outcomes in the sample space, in this case head and tail, to real numbers, where head is mapped to 0 and tail is mapped to 1. Let's look at another example. Say we have a random experiment where we toss 3 coins. Now here I've defined the random variable x as number of heads that appear. So when you define the random variable, you determine the mapping. This is the rule based upon which the outcomes in the sample space get mapped to real numbers. In this case, the rule I've defined is count heads. Basically, what I'm saying is x is defined as the number of heads. So each outcome is assigned the count of head it contains. Over there, we define the random variable by explicitly specifying the numbers I want it to take, right? I specifically said I want head to take 0 and tail to take 1. Here we've defined the random variable a little differently. Here we've defined it based upon the count of heads. So, but this is going to determine the mapping. I'm saying x is defined as the count of heads. So basically what I'm defining is that in this case, the mapping is going to be based upon the number of heads each outcome contains because we defined x as the number of heads. So the random variable x is going to map outcomes to real numbers based upon the number of heads each outcome contains. So since tail contains 0 heads, x is going to map this outcome to the real number 0. Since head, tail, head contain one head, it's going to map each of these outcomes to 1. And since head, tail, head, each contain 2 heads, so it's going to map them to 2. And head contains 3 heads, so it maps it to 3. So this is a random variable mapping. So remember, whenever you define the random variable, you determine the mapping. This is the rule based upon which we are going to basically map our outcomes in the sample space to real numbers. In the previous example, we defined it in such a way that we said map head to 0, tail to 1. So this was a rule based upon which we were assigning the mapping. Here, we defined it as the number of heads. So this is the rule based upon which it's going to map. What it's going to do is that since we're defining the random variable as the number of heads that appear, it's going to assign each outcome in the sample space to a real number based upon the number of heads contained in that outcome, right? So this is how the random variable mapping is going to work, where it's going to map the outcomes in the sample space to real numbers. And here note, for each outcome, we have exactly one number, like tail to tail gets mapped to 0, head tail gets mapped to 1, head gets mapped to 2. But like we said, you can have multiple outcomes mapped to the same number. Here we have 3 outcomes mapped to the same number, right? Head, tail, head, tail, head. Similarly, here we have 3 outcomes mapped to the same number. Like we said, for each outcome, you get exactly one real number, but you can have multiple outcomes corresponding to the same number. Like here we have 3 outcomes corresponding to 1, and here also we have 3 outcomes corresponding to 2. Now, if you look at random variable notation, conventionally, random variables are denoted by capital letters X, Y, and Z, and the values they take with lowercase letters, right? So in the first example, the random variable X was, we define the random variable with uppercase letter X, and if we want to refer to its values, 0 and 1, we'll use lowercase letter X. Similarly, here we define again the random variable with uppercase X. If we want to refer to its values 0, 1, 2, 3, we'll use lowercase x. Now, just one final note on values or random variables. Random variables only take numeric values, and that makes sense, right? Because we said we're defining it as a function that maps outcomes from the sample space to real numbers, right? So it's taking outcomes in your sample space and assigning them numbers, so the random variable will take numeric values. So in the first example, it took values 0 and 1. In the second example, it took values 0, 1, 2, and 3. Now, to see the exact actual value the random variable takes, we need to do the experiment. Before the experiment, we only know the possible values it takes. Like before we toss the coin, we know the random variable X could take a value 0 if head appears, and it could take a value 1 if tail appears. But exactly which value it takes, that will be determined once you perform the experiment.